Hello everyone. Uh, we are on a full stack open and uh, part D, more complex state and debugging React app. We'll do this in next few days, and I really feel like doing React right here is a good part. The great approach is first read all the docs. I mean, not all the docs at once, obviously, but try to read all the docs or majority of the docs, React docs. So then when we transition to full stack open, and it will be a hell lot easier for us to, I mean, start making sense of these things. And there are a lot of knowledge heavy, documentation there is. And uh, there are three parts basically describing UI, basically four, but most important one are three. Oh, why it's not, let me reload. Okay, first is describing UI. Describing UI. In describing UI, there are a lot of beginner level. First component writing, we know. Importing, exporting, we know JSX, we know JavaScript, we can use JSX in curly braces. We know props, we know conditional rendering. We don't know, but we will get to know really soon. And rendering lists also, keeping component pure. In whole this, section, the most important thing, which is I think uh, technically, more technical and more fundamental to Act philosophy, is keeping components pure. I think. I mean, before moving to next sections, I think this one I should go through this one and make sense of it, and it will add a lot of knowledge and make a mind like, hey, what is the philosophy behind React of keeping component pure, or functional programming kind of thing. React is nowadays a functional programming driven uh, approach. So we must have to go through this section to make sense of functional little bit. Functional programming is used. By the way, functional programming is a huge, and few concepts of functional programming are being used in React. And first one and most one is, immutability and keeping component pure. These two things are basically a mostly emphasized. So let's go. Keeping components pure. What it means to be keeping components pure. We will look at this today, and maybe adding interactivity some sections. So some JavaScript functions are pure. Pure functions are only perform calculation and nothing more. But strictly only writing your component pure function, you can avoid entire class of baffling bugs, unpredictable behaviors as your code base grows. To get these benefits, though, these are few rules you must follow. You will learn what is purity and how it helps to avoid bugs, how to keep components pure, keeping changes out of render phase. We must have to know render phase. What is render phase? When page loads or component loads, it renders a JSX and state, associated to it. And other than these two things, prop state and JSX, component does not render or does not execute or invoke any other thing. We will see this later. Let's go. How to use strict mode and find mistakes. Okay, purity component as a formulas. In computer science and in the world of functional programming, pure function is a function whi- which with the following characteristics. It minds its own business. It does not change any object or variable that existed before it was called. And really, knowledge heavy line. Existed before, it means when function is created in a program memory, and when before that whatever existed, it does not play with this, it does not touch even those things. It will just play in his own variables. Okay, same input, same output. Giving same input, a pure function should always return same result. Okay, you might already be familiar one example of pure function formulas in math. Consider this math formula: y is equal to 2x. If x is equal to 2, okay, 2 into 2 4, y is equal to 4 always. X is equal to 3, we will get 6. If x is equal to 3, y won't sometime 9, sometime minus 1, sometime 2.5, depending on the time and day and the state of the stock market. No, this will not happen. If y is equal to 2x, then 3 will be always 6. If we made this into JavaScript function, it would work like this. Function double number return 2 into number. In above example, double is a pure function. If you pass 3, it will return 6 always. Okay, if we pass 5, it will return 10 always. Okay, React is designed around this concept. That's why I was telling that this is a fundamental, a foundational thing. We should really must have a good grasp on this concept to really write effective React code. React assumes that every component you write is a pure function. This means that React components you write must always return the same JSX given the same inputs. Okay, inputs are here, I think, props, obviously. Okay, let's see. Function recipe, we are providing a drinkers and boil drinkers cup of water, add drinkers spoon and zero point 0.5. Okay, what it is, 0.5, 0.5 into drinkers. Okay, here we are calling recipe drinkers is equal to 2. Then boil 2 drinkers cup of water right here. Add 2 spoon of tea and 1 spoon of spice. Okay, we are again calling, and right now we are providing 4 as a prop, and then we are getting same results. After multiplication, show more. What to show more? Okay, this is it. This is it. You pass a drinkers 2 to recipe, it will return 2 cups of water always, obviously. If you pass 4, it will return 4 cups of water always. Okay, just like a math formula. Okay, let's go. You could think your components as a recipe. If you follow them, don't introduce new ingredients during the cooking process, you will get a same dish every time. That dish is JSX and that component serves to react to render. Okay, we can think our components as a recipes. We provide same inputs, we will get same outputs. Okay, a React rendering process must be pure. It means, React component, inside component, there are a lot of stuff happening like fetch calls or whatever, not whatnot. So everything can't be pure. So React rendering process must be pure. Okay, this rendering process. And what is rendering process? Rendering process involves JSX rendering and rendering a whole component inside like state and props and JSX. I think these three three things include React rendering process, but I think it would be better to consult to some AI and ask him what includes React rendering. Components should not only return their JSX and not change any object variable that existed before rendering. It would make them impure. Here a component that breaks the rule. Let's guess. This existed before a function cop, okay, and before a function test and the function cop is playing with this, so it is impure function. Let's go. This component regarding guest, I think I should not read this. We should pass a guest right here. This guest as a prop, and we are good to go. Okay, we got answer from here. Although you might not have used them all of yet, React, there are three kinds of inputs that you can read while rendering. Okay, props, state, and context. You should always treat these inputs read only. Okay, when you want some to respond input sets, you should use set state instead of writing a variable. You should never change pre-existing variable or object while your component is rendering. React offers strict mode which calls each component function during development. By calling component function twice, strict mode helps to find components that break these rules. How? When we'll render a component two times, if we are, like here, if this is a state, if this is a state, then guest plus one. We think they don't exist. We log and we will find, hey, this is adding up. Maybe when you want to change something responsive user set state instead of writing to variable, you should never change pre-existent variable. If we are changing pre-existent variable, when we will do two times render two times, they aren't gonna be changed, by the way, I think. But let's say, notice how original example displayed guest to guest instead of guest one, guest two, guest three. Okay, 0 and y here is 2. Notice how original example displayed 2, 4 and 6. Why? Because, oh, got it. This will display 2 because every component is getting rendered 2 times. So once 1 and then 1 plus 1 2 and then 2 here and 2 plus 2 4. Okay, 2 plus 1 plus 1. Yes. 4, then here's a 4, 4 plus 1 plus 1. Everything happening rendering twice. That's why we are getting this unexpected result. But what we want to achieve is this. How we can achieve this? We are just props. Okay, just providing props. We want to guess 1 2 3 and we got them really easily. Okay, let's go. What I have to copy? What includes In above example, the problem was component change pre-existed while rendering, often called mutation to make a sound bit scarier. Pure functions do not mutate variable outside of function scope objects that were created before the call that makes them impure. Okay. However, it's completely fine to change variable objects you have just created while rendering. In this example, you can create an array and cover push and do whatever you want. Okay, any variable we created inside a function, we can play with it however we want. Okay, no one is stopping us. The thing we can't play is outside a function. We are uh, outside a function, any variable or any object or array or whatever a data type data structure is. Okay. uh, State changes, batching, what is he is doing. He is going so deep. Leave it. Okay. However, it's fine because you have created them during the same render. I mean, I mean, let's look a simple React component. This is a React component. This is bit, I think, yes. Hmm. I mean, let's do some examine. Let's examine stuff. I mean, let's run npm run dev. I mean, let's examine some stuff. I mean, what renders on initial render? I mean, on a rendering process, every render it means. Okay. What renders on a rendering? I mean, what get logged or what happens? I mean, what are the things which got rendered? I mean, state and props and context, use effect maybe or not. Let's see. Let's see. I mean, we'll do a little, I mean, scary stuff, interesting stuff, I think I should say. I mean, first of all, I will do what? Yeah, this is perfect example, by the way. This is perfect example. Okay, it, I mean, I should pass a prop. Okay, counter. Okay, in prop, I mean, this counter prop is not good example. I mean, let's name is equal to name or my name. Okay, okay, I'm getting props and I'm logging props here. Okay, and also rendering counter value. I mean, this is a and this is. These two will not render or anything inside log will I get rendered or not. Okay, anything right here will rendered. I mean, okay, these are, I mean, event handlers. I mean, these will only run when on click event will happen. Okay, these will not get rendered, but anything else like props, state, or context, which we haven't learned yet, will get executed or run or invoked or rendered on every render. Okay, on every render means on re-render also. Re-render also, everything will be get rendered on re-render. Okay, we on zero, once re-render, here is re-rendering happening and everything is getting rendered or logged or executed. Look, increasing before 27, this is it. No, this is not. Okay, this is event handler stuff, but name props will get executed. Okay, state, obviously state, here it is, this will get rendered. So state, prop, and context value will get renamed. By the way, context is basically a state but a global one. Okay, so state and prop will get rendered on every render, get executed, get invoked, whatever you want to say. But yeah, this will happen on every render. So when we are talking about purity, so state and prop will render on every render. Oh wow. Although you might not have used all of them yet, there are three kinds of inputs that can read will be read props, and you should always treat these inputs as a read only. So when you want to change something in response to user input, you should set state. So any kind of data we want to play, we must have to add it in a state. Okay, I mean anything we wanna add to a UI. If you wanna we wanna display something to a UI, we must have to add it as a state, and then it will be a reactive way to do things, and then it will work basically. It will not work. I mean, let's say let number. Oh wow. Let num is equal to 1, and let's say here I did num and increase by num plus 1 instead of, I mean, let's say I commented out this and do num plus 1, and that's it. Now plus will not work. Plus will not work because this is not a React way to doing things. If we want to show the thing to a UI, we must have to provide it in a state. So React can trigger a re-render and can trigger can update a UI. Okay, now if we do this, this will update the UI. So I basically downloaded from a YouTube a really good conference talk about React way of React model of UI, building a UI. There are a couple of models like MVC and whatnot, but React way is unidirectional data flow, immutability, and functional programming way, declarative UI library, and we'll watch this together. I mean, really soon, but right now, I think completing this will be more beneficial. Okay, in above example, the problem was component changed pre-existent variable while rendering. What's happening here? Okay, let's go to side effects, where you can cause side effects. While functional programming relies heavily on purity, at some point, somewhere, something has to change. That kind of point of programming, these changes, updating a screen, starting and changing the data called side effect. They are thing happen on a side, not during rendering. Okay, like this can be count as event handler. In this event handler, we can do a side effect. Okay. This will not get rendered during rendering. This will not get invoked. I should say, sorry to say, I should say invoked or executed. In React, side effects usually belong inside event handlers. I mean, right here, obviously. Event handlers are functions that React runs when you perform some action. Okay, when I click here or click here, then React will run this increase by one function or event handler. Okay, for example, when you click a button, I click a button. Even though event handlers are defined inside your component, look at them, they're inside my app component. They don't run during rendering, so event handlers don't need to be pure. Event handlers don't need to be pure. So event handler can modify outside world. Things like counter does not belong to event handler. Like this is not defined right here. This is defined outside of this function. This function is actually an impure function, but this doesn't matter for impurity for event handler. But at least the component is pure. While we are debugging our app, we know if some bug is happening, this is inside this component. We don't need to go to another component. Okay, if you exhausted all other options, you can't find right event handler for your side effect. You can still attach it to your return JSX using useEffect to call your component. I mean, anything we'll get from internet, or I mean from API call or whatever, from wherever or whatever, we need to eventually need to display on a UI, and for adding to UI we must have to use state. Okay, and if we don't see a place where we want to do some action which is a side effect, obviously, I mean everything is a, I mean outside of React use state is a side effect. I mean everything which we do out of component is a side effect. Then we, I mean, like what kind of side effect? Yeah, reading a local storage, reading of data from local storage. We want to read data from a local storage when user visit our site. There is a no event handler can be attached, I think. Maybe, I mean, on click or button or whatnot. Then we will add a use effect hook. We will learn about a use effect hook really soon. And when use effect hook will, I mean, run a side effect and add that kind of data if we need to state, and then we will display to our UI. Okay, this tell React execute it later. I mean, uh, execute it later after rendering when side effect. However, this approach should be your last resort. Okay, why React does care about purity? When possible, try to express your logic with rendering alone. You will be surprised how far this can take you. Okay, we'll do a recap and we will do these examples and we'll move on. Move on. Let's do this recap. A component must be pure. It minds its own business. Same input, same output. We read this earlier. Rendering can happen at any time, so components should not depend on each other rendering sequence. You should not mutate any input out of your component use for rendering that includes props, state, and context. To update a screen set state instead of mutating pre-existing objects. I mean, you should not mutate any inputs. It means we cannot mutate props, state, or context value. We just use them. Or if we want to update, we will do a set state, which will tell React, hey, the state is changed, do a re-render. Okay, strive to express your component logic in JSX you return. When you need to change a thing, you will usually want to do it in an event handler. As a last resort, you can use that reuse effect. Writing pure function takes bit practice, but it unlocks power of React paradigm. Okay, try out some challenges. Okay, challenge one: fix the broken clock. I mean, what's going on? Here we will do. I mean, we should not mutate outside thing, and this is the outside thing. We just can return. I mean, when you forget return. Oh, and what happened? Day or night? And what will happen? I mean, it's showing a time also, but when I do this, I don't know, show solution to me. Okay, I mean, I didn't read this carefully. I think let's fix broken profile. What's wrong with this? I mean, let's read. The profile component are rendered side by side with the different data. Press collapse on a first profile and expand it. You will notice both profile now show same person. Okay, this is a bug fix. Find the cause and fix the bug. Pretty interesting. I mean, let current person. The issue is totally. I mean, who is the profile parent component? I mean, this one, or this one? I think this one. Okay, we should not do this. I think. I mean, no. What's going wrong? Okay, profile and profile is getting person. Okay, letter should get person name is equal to dot name. Okay, and now get person name and it should do this. I think names are changed. Yeah, I think I fixed it. Now names are different, but picture are same. I think different. In Avatar also need to do this and I mean just copy this and paste it right here and do what I mean I'll copy this, paste this, and I mean, alt doesn't matter, but let's say now picture is gone. Shubrakam Shugalatka. Why picture is gone? Picture should come up. I mean, person name. I mean, let's see. Solution. Okay. I mean, we to get an image URL, we need to provide a whole person object, not person name. So here we can pass just a not a person dot name, but a person. Okay, we got it. I mean, the third one. Fix broken story tray. What it is? Oh, the CEO of the company is asking to add a stories in your online clock app, and you can't say no. You have written a story tray component. Okay, this is a story tray that accept list of stories and followed by create a story. Okay. Create story placeholder. You implemented create story placeholder by pushing more fake stories and end up the stories and got it. I mean, it will be hell lot easier, but why it's looking like a only one component? Only one component. We are getting stories from where? I mean, just do this, I think, and create story still appears more than once. Can I log stories? Dot log. Oh, no, two stories are okay, but where is the create story? Let's see a solution. This is a solution what I proposed. Okay, there must be a li. Only create story. Okay, copy this and paste this wherever you want. Like here, create story. Now user will click to create story and can create story. By the way, this is enough. UI as a tree. I think this is another important. Really, really important. Let's go through it. I mean, bit quicker. Let's go through. I mean, we'll go bit quicker because yeah, there are concepts, but not. I think really technical, really. I mean, mind-boggling. Understand your UI as a tree. Okay, if my UI is a tree, your React app is taking shape with the many components being nested within each other. How does React app keep track of your app component structure? React and many other UI libraries model UI as a tree. Thinking your app as a tree is useful for understanding relationship between components. This understanding will help you debug future concepts like performance and state management. Okay, how React does see your component structure, what render tree, and what is it useful for, what module dependency tree, and what it is useful for. Let's go on. Your UI as a tree. These trees are relationship model between items and UI, often represented using tree structure. For example, trees are relationship model between items and UI, often representing using tree structure. For example, browser use tree structure to model HTML and CSOM, and DOM. Mobile platform uses trees to represent their view hierarchy. Component A, B is a child and C is a child, and both of these are sibling with each other, and A is a parent and whatnot. Like browser, mobile platform React also uses the tree structure to manage and model relationship between components in React app. These trees are useful tools to understand how data flows through a React app and how optimize rendering and app size. Okay, the render tree. I mean, a major feature of component is ability to compose components to other component. It means composition. As we nest component, we have a concept of parent and child components where each parent component may itself to be a child of another component. When render a React app, you can model this relationship in a tree known as the render tree. Here is the React app render inspirational quotes. One, two, three, four, and four components down there. App is a great parent or grandparent. Fancy tree, inspirational generator, or what it is, copyright, inspirational. I mean, app is a father or parent of fancy, and this is a parent of copyright. This inspirational generator. Look at inspirational generator. I mean, this is taking a children, and the children where he is oh, fancy text. I mean, fancy text is I mean, oh, the shared structure is wow. That's it. App, app. Look at the app. Fancy text. Okay, fancy text is a child of app and inspirational generator. Okay, then inspirational generator. Go to inspirational generator. Okay, inspirational generator has two more two children. Fancy text is the children of app and children of inspirational generator, and copyright is the children of inspirational generator. It means when the children can be a two types. One is direct here children, okay, and second is we import a component and use inside the other component is the children. Two types of children. I mean, two way to use a children or two ways to write a children, whatever we say. Yes. From the app example, we can construct above tree nodes in our tree. The tree composed of node, each of which represent a component. App, fancy text, and copyright. App, fancy text, copyright, inspirational generator also, by the way. To name a few, not all, we are all nodes of our tree. The root node of React tree is the root component. Root component is an app root component. Let's see main.txt or app. Your first component. Who is the root component? Root component is the this app.js or app.ts. Where are the HTML tags in a render tree? You will notice the above render tree there is no mention of HTML tags of each component render. This is because render tree is only composed of React components. React is a UI platform or framework is a platform agnostic. On React.tab we showcase examples that render to the web which uses HTML markup to its UI, but React could just be likely rendered to a mobile desktop which may use different UI primitives like UI view or framework element. Okay, so component, React, and all of this is React stuff. It has nothing to do is a platform specificity. That's why we can plug React to any platform, UI platform. A render tree represents a single render pass of React application. With conditional rendering, a parent component may render different children depending on the data passed. Okay, render tree. We use conditional rendering somewhere and render tree change. Okay, other than that, everything is good to go. Okay, we don't know conditional rendering yet. That's why I'm skipping this part. But conditional rendering is pretty simple. I mean, where it's doing conditional rendering. Let me see. Inspirational generator. Just add this. This. I mean, what we say it's alternative of if statement. I mean, ternary operator. Just use ternary operator and we are conditionally rendering. Do a conditional here. Inspirational type is equal to quote. If it is equal to quote to this, else to this, and that's it. I mean, conditional rendering. Whole chapter of conditional rendering is here. I mean, okay, conditional rendering whole chapter is there. I think we will not go through this today. Someday, really soon, we'll go through a conditional rendering, but really basically, and this is conditional rendering using ternary operator. The module dependency, another relationship in React that can be modeled with a tree or app module dependency. As we break up our components and logic into separate files, we can create JS module where we may export components, function, and constants. Each node module dependency tree is a module and each branch represents import statement to the. Okay, two types of children's, one using import and one using directly when it come between the components, like. Okay, app imports copyright, fancy text, and this and that. This is super important because I. And then recap, and then we officially completed two, three things. Okay, let's read this one also today. I mean, today's session will be a smaller one maybe because I started late and I end earlier when at 11 maybe. Then I'll sleep. I have to sleep to wake up early and go to my job. Let's read this, by the way. The root node of the tree is the root module. Okay, like this. This is the root node. This is the main JSX, and there is a one node, by the way. Super simple. Comparing the two render tree of the same app, there are similar structure but some notable difference. The node that makes up the tree represent modules, not components. Non-component modules like inspirational JS are also represented in this tree. The render tree only encapsulates examples. Copyright JS under but render tree copyright the component appears as a child of inspirational JS because except JSX children props so render copyrights as a child component not. What the hell is going on? I mean, does it make even sense to me? Should I do a YouTube React render tree? Copyright. I mean, let's go. Inspirational JS, non-component modules like inspirational JS. Let's go to inspirational JS. Why it's a non-component module? By the way, it's a component. Look at here. Look at this. It's a component. Why? Non-component modules. Copyright JS appear under app.js, app.js, copyright JS. Okay. But in a render tree copyright, the component appear as a child of inspirational generator. Inspirational generator cup. What it means? Inspirational generator's child. How it can happen? It's happening. I don't know. Because inspirational generator accepts JSX as a child prop, so it renders a copyright as a child component but does not import the module. Dependency trees are useful to determine what modules are necessary to run React app when building the React app for production. There is a typically build step that will bundle all the necessary JavaScript shipped to the client. The tool responsible for this is called bundler. I mean, this guy, client side tooling. Package management. This worth to read, I think. Should I bookmark this? Understanding client-side tooling. Yes, I'll read later someday, maybe. As your app grows, often bundle size does too. Large bundle size expensive for client to download and run. Large bundle size can delay the time for UI to get drawn. Getting sense of apps dependency tree may help with the debugging these issues. I mean, do a lazy loading if your bundle is huge. Let's do a recap. Trees are common way to represent relationship between. I mean, let's do a react. What render trees or what I should say? This name it. What I should name it? I mean, react render trees. What it means? No, no rendering, not rendering. React UI as a tree. Some guy will come up and teach me. Mhm. Data science for everyone, and they are teaching React. What the hell is going on?
Welcome back, everyone.
I mean, I expected illustrations and some whatnot, and they are doing a code thing. Let's do a recap. I mean, render tree represent nested relationship between React components across a single render. Okay, with conditional rendering, the render tree may changes across a different render. Okay, with different prop value components may render different children components. Render tree helps identify what the top level leaf component are. Top level component affect the rendering performance of all components between beneath them, and the leaf components are often re-rendered frequently. Identifying them is useful for understanding and debugging the rendering performance. It means the parent component should not be enough heavy or enough doing a state change in parent component, which cause a re-renders to all its parent children's, and it cause a performance, I mean, low performant apps. This is trying to, they're trying to tell us, okay, let's go. Dependency tree represent module dependency, React app dependency tree used by build tools. I mean, dependency tree is a really build tool thing I should not worry a lot about. But yeah, having a knowledge about dependency tree when we are learning, you're learning Webpack stuff somehow. By the way, Webpack is too old right now. World use wait, but somehow if you have to learn a Webpack, might you need dependency tree knowledge. But this is enough knowledge, I think. Enough is enough. Let's go to adding interactivity. I mean, I think this chapter or this section is a lot. I mean, first of all, I mean, this section will take at least my 5 to 10, 6, 8, 10 maybe hours, but let's go. Something on the screen update to respond. Something on the screen update in a response to user inputs. For example, click in an image, gallery switches to an active image in React data that change over the time called state. I mean, not in React, in a whole world. The data change over time is called state. You can add state to any component and update as it's needed. In this chapter, you will learn how to write components that handle interactions, update their state, and display different outputs over time. Responding to events. Play a movie, upload an image. I think we went through this. Okay. It looks like this is a complete intro to all of this section in one documentation page. And if you want to go through each of this, then you are good to go. I mean, we went through responding to events, I mean, few days back, and state a component memory. I think we went through this also. I think, but no, this is a huge, and it means huge. And render and commit. I mean, tomorrow we will do a state, render a commit, state is a snapshot, this, all of this. Not. We will be able to do one and two and maybe three. Okay, this is enough for today. I mean, tomorrow. I mean, my goal is to complete a React docs before jump to a more React in full stack open. But let's see. I mean, where things go. I mean, I'm just documenting my study. I mean, I study. I don't want to really keep a strict rules to complete this and that in these this much days. No, I learn this much. I mean, this way I learn. I mean, really, I love to learn things in depth always. And when it comes to React and you want to write a React code, you must need to know a React better. I mean, there is a reference page. Okay. So I know these days might feel hard to me and you also, but after getting through this documentation, all of this, I mean, look at this: one React, two React courses, three React, 4 React, 5 React. All of these 5 React, this becomes like half of the full stack open. I mean, there is a 13. I mean, 5 of them will become a lot easier and make a lot of sense to us. And that's why I'm reading React docs. I mean, it feel a bit daunting maybe, but bear with me for now, and eventually it will pay off, I think. And this is it for today. And on the next day, maybe on the morning, if I wake up earlier, I'll spend 1 to 2 hours, and maybe I will read. No, this not. Not this one, maybe this one, a state of component memory. Okay, goodbye. I mean, see you tomorrow. Bye bye.